Class, in this video, we pick up our discussion in section 6.4 of your textbook on the inverse trigonometric functions. So we're going to be starting at the top of page 14 of your note packet. And in this page, we're going to be evaluating some mixed composite functions, where we have, like in the first example, we have the composite of the inverse sine function with the tangent function. So we have to evaluate the tangent of the inverse sine of 1/2. What's that composite equal to? Well, the outer function is the tangent function, so we know the answer is going to be a number, right? Because you know the tangent function, you input an angle and it outputs a number. Well, the inverse sine of 1/2 from page 3 of your note packet is equal to 30 degrees or pi over 6 radians. In these kinds of composites, right, I can actually use degrees instead of radians if I want to for the angles. So the inverse sine of 1/2 from page 3 is equal to 30 degrees. So this composite is equal to the tangent of 30 degrees. And from the unit circle, the tangent of 30 degrees is 1 over the square root of 3, or square root of 3 over 3. So this composite is equal to 1 over square root of 3, which is equivalent to square root of 3 over 3. In the next example, we got to evaluate the composite, the cosine of the inverse sine of square root of 3 over 2. Well, from page 3 of your notes, the inverse sine of square root of 3 over 2 is equal to 60 degrees, and the cosine of 60 degrees is equal to 1/2. So this composite up here is equal to 1/2. And lastly, you got to find the sine of the inverse tangent of -1. Well, from page 6 of your note packet, the inverse tangent of -1 is equal to -45 degrees, and from the using the unit circle, we know the sine of -45 degrees is equal to minus square root of 2 over 2. So this composite up here is equal to minus square root of 2 over 2. On page 15 of your note packet, we're going to evaluate the mixed composite, the cosine of the inverse sine of 4/5. Now, 4/5 is not a number on the unit circle, right? And 4/5 is not a number you'll find on page 3 of your note packet. So we got to do something a little bit different. We're going to use right triangle trigonometry. Inverse sine of 4/5, you know, is equal to some angle between -90 and 90 degrees. So we're going to set theta equal to the value of that angle, inverse sine of 4/5. We've been using theta as a variable for angles since we started studying trigonometry. So theta, the angle theta, is equal to the angle inverse sine of 4/5. Well, from page 3, in discussion on the domain and range of the inverse sine function, we know that the sine of this angle theta has to equal 4/5. And from right triangle trigonometry, the sine of theta is opposite over hypotenuse, which in the coordinate plane is y over r. So the sine of theta is equal to 4/5, which is equal to y over r, which is opposite over hypotenuse. So the opposite side in our right triangle, here's theta, the opposite side y is equal to 4, and the hypotenuse r is equal to 5. And we're going to have to figure out what the length of the adjacent side x is. Okay? Well, because 4/5, the number going into the inverse sine function, is a positive number, we know theta is an acute angle between 0 and 90 degrees. And that's why we can use right triangle trigonometry, because theta in a right triangle is an acute angle between 0 and 90 degrees. So using the Pythagorean theorem, x squared plus y squared equals r squared, right? We find that x, the length of the adjacent side, is equal to 3 units. So for our triangle up here, the cosine of theta is equal to x over r, right? Which is adjacent over hypotenuse, is equal to 3/5. But, right, so cosine theta is equal to 3/5, but theta is equal to the inverse sine of 4/5. So we replace theta here with the inverse sine of 4/5, and we have the cosine of the inverse sine of 4/5 is equal to 3/5. And that's what we were asked to find up here. The cosine of the inverse sine of 4/5. And so using this right triangle, we found the value of that composite. The cosine of the inverse sine of 4/5 is equal to 3/5.